Hello everyone, welcome to the problem discussion session today. So today the problem is on the basis of the electrostatics as well as it combines the concepts of SHM or simple harmonic motion. So this problem was asked in JEE Advanced 2024 paper 1. Now let us look at this problem. It is two beads each with charge Q and mass M are on a horizontal frictionless non-conducting circular hoop of radius R. One of the beads is glued to the hoop at some point, while the other one performs a small oscillations about its equilibrium position along the hoop. The square of the angular frequency of the small oscillations is given by option A, B, C, D. Okay. Now let us visualize the problem and let us draw the diagram of the problem, how it will look like. Okay. So it is said that the circular hoop of radius R. Radius is R. So one of the charge Q is fixed or glued at some point and another charge is oscillating. So what will be the equilibrium position of another charge? This is the equilibrium position of another charge because this charge will repel each other, right? But this is fixed, so it cannot move. So this can move only along the circular hoop like this in this direction. So at this position, it will only have radial component of the force, that is the electrostatic force. Electrostatic force. So at this position, it is not having any tangential component of that force. The entire force is electrostatic force is radially outward. Okay. Now what happens if you displace it little bit in suppose this direction by small angle theta? So what it will happen? This will get electrostatic force from this plus Q charge which is glued. So this will be in this direction, FQ. And what is the amount of the force? 1 by 4 pi epsilon naught Q into Q by the distance square. Now what is the distance? This is the distance. This is the distance, D. So let us say D square. That is the amount of force here, Q. I hope this problem is visualized completely. Now we'll go to the fresh diagram. This is the fresh diagram I have drawn for you separately. So it is displaced by small angle theta. If this is theta angle, how much angle this distance or D it will make with this radius? Theta by 2 only, because if this is theta, this must be theta by 2, and if this is theta by 2, this angle should also be theta by 2 because this is R, this is also R, so the angle will be same. And FQ is directed along this line joining these two charges plus Q and plus Q, so it will be like this outward. Now see, this force or this electrostatic force, that is 1 by 4 pi epsilon naught Q square by D square, that is not entirely radial. So it is having one component in this direction or the tangential direction. And another component is radially outward, that will not cause the oscillation. Rather, this tangential component of this force, it will make this charge to come to this point, again to the mean position or the equilibrium position. But it will not be able to stay here because of some velocity it will achieve. Then it will go somewhere here. Then again it will come back here because it will have that time, it will have some tangential force in this direction towards the equilibrium position. So it will oscillate like this, to and fro motion like this. What is the component of force that is trying to restore the equilibrium position? FQ cos of this angle. So what is this angle? If this is theta by 2, this is the opposite angle, this is also theta by 2. So this angle is 90 degree minus theta by 2. So what is the restoring force? Restoring force. FQ cos 90 degree minus theta by 2. That is necessarily f cube sine of theta by 2. Now what is the distance? See, the distance d, this is r radius. So this is r cos theta by 2. And this triangle, this is also r cos theta by 2. So distance is becoming, d is becoming r cos theta by 2 plus r cos theta by 2, that is 2r cos theta by 2. We'll put that. So the restoring force Fq sine theta by 2 is causing it to go to the equilibrium position. So we can write that is equal to mass into acceleration. We can write minus also because it's restoring force. So what is the amount of Fq force? 1 by 4 pi epsilon naught q square by d square. D square is, we have found out the value of d, that is 2r cos theta by 2. As theta is a very small angle, we can write cos theta by 2 is equal to 1 only. We can write 2r only. And if theta is very small, then sin theta by 2 will be the angle only, theta by 2. That is equal to m into a. Now, a is the acceleration towards the equilibrium position. Acceleration is necessarily angular acceleration into r. Is the rate of change of angular velocity. So we can write that it is d2 theta by dt2 to r. So we can substitute here m into r into d2 theta by dt2 equal to minus of q square by 2 to 4, 4, 4, 16. 16 into 2 is 32. 32 pi epsilon naught r square. And that we can write it here. d2 theta by dt2 is equal to minus of q square by 32 pi epsilon naught r cube m into theta. So this is our standard SHM equation or the simple harmonic equation or oscillation equation. So what is the standard equation of the SHM? d2 theta by dt2 is equal to minus omega square into theta. So upon comparing these two equations, we'll get that here omega is the angular frequency. So what is the omega square here in this equation? Q square by 32 pi epsilon naught r cube m. This is our answer, and that is asked in the question. So what is the answer? Answer is option B. This is our correct answer. I hope you have understood the problem. Thanks for watching.